Hello, hello. Okay, so we're on part 2 of substitution. If you have not watched the part 1, oh my goodness, you're going to want to watch the part 1. Today's problems are just going to get more difficult, more interesting. So please watch those so that you can get a little bit more of a foundation in. Okay, so we're still doing substitution. We're just kind of looking at some more interesting situations. So we are going to write down some steps so that if you get stuck, you can look back here. Okay, and this is for substitution. Okay, so first step, step 1 is to isolate, and that means get it by itself, right? You're going to isolate X or Y. It's your choice. You can choose to isolate X or Y in either equation. Okay, and then I'm going to write choose wisely. Okay, you're going to isolate X or Y in either equation. You can isolate X or Y in the top, in the bottom. It doesn't matter. If you look at the examples we did last class, I gave you a variable already isolated. I started you off with this X already being isolated. X was by itself on the left. In this system, Y was isolated. It was by itself on the left. Okay, so I kind of did that step for you. But now we're going to move on where you have to do that yourself. You have to do some rearranging and either get X or Y. Doesn't matter if it's in the bottom equation, top equation, you could do X or Y in either one. So you kind of have like 4 different possible variables that you could isolate for this. Okay, choose wisely means sometimes there's a smarter choice. So like in this problem, even though I already isolated X for you, you could have isolated this Y up there if you really wanted to. You would move the 8X over, divide everything by -6, and you would have your variable isolated. But why wouldn't you just go with this since it's already isolated, you know? That's what I mean by choose wisely. Step 2, after you have X or Y isolated in either one, step 2 is to substitute, which you can say plug in if you really want to, or replace. Substitute this expression, and what I mean by this expression, like this right here, X is isolated, that was step 1, and then we substituted this expression, Y plus 5, that's what we substituted in for X in the other equation. So substitute this expression into the other equation and solve for the variable. Substitute this expression into the other equation and solve for the variable. So once again, this is what we were doing last class, okay? So we took this isolated variable, we replaced this expression into the other equation, and then we ended up solving for Y, okay? And then the next thing we did is we took that answer for Y, plugged it into either equation, solved for X. Okay, so step 3, substitute your answer. So the answer you just got when you did step 2, substitute your answer into the equation from step 1 and solve for the other variable. Okay, so those are your steps. Pause the video if you need to catch up. Okay, this is what we did last class. It's just we're going to have more difficult problems coming your way. Okay, so here we go. Here's your first example. First equation in the system, 6x plus y equals 27. 6x plus y equals 27. Second equation, negative 5x plus 4y equals negative 8. Okay, so that's your system. All right, and we're going to do step 1, 2, and 3, and I'm going to make it very clear in our notes and in your notes. Step 1, step 2, step 3. Okay, so in fact, I'm just going to go ahead and force some room for myself. Step 1, step 2, step 3. Okay. All right. So here we go. Step 1 said isolate x or y in either equation. Okay. So I have choices. I could isolate this x, I could isolate this y, I could isolate this x, or I could isolate this y. 4 choices. To choose wisely. Well, to isolate this x, let's think about what we would have to do. It means get by x by itself on the left. I would have to move over the y, so subtract the y, and then I would have to divide everything by that 6. It's not terrible, but it takes some time. But if I choose to isolate this y, the only thing I would have to do is just minus the 6x. Because notice how y doesn't have a coefficient in front. That means I wouldn't have to divide all the things by some number. So this would be the best one. Everything else has a coefficient attached to it. So right away I can tell that this would be the easiest variable to isolate. So this dude right here. So I am going to take that first equation. I'm going to write it right here. 6x plus y equals 27. And we're going to make sure everybody remembers how to rearrange equations. Okay. If the goal is to isolate this y, well, I want to leave it. I want to leave that y over there. But I don't want this 6x on the left. I want to move it over. To move it over, technically I have to subtract 6x. 6x minus 6x cancels. I'm left with y equals something. Over here, 27 minus 6x. Those are not like terms. I can't put them together, right? So I would suggest dropping down your x term, plopping down your constant at the end. So if you rearrange this, it's the same as y equals negative 6x plus 27. Okay. Y is isolated. That's step 1. Okay. Now what we get to do, we get to take this expression. So maybe circle it. We're going to take that expression, and I want you to tell yourself that we're going to plug in for y. This entire thing, negative 6x plus 27, that is what we plug in for y. So that's going to be step 2. I'm going to take that and I'm going to plug it in for y. In which equation now? Well, I'm going to do it in the other equation. Since we manipulated this first one, we're going to plug it into the second one. Okay. So I'm replacing it with this right here. This y is being replaced. So the negative 5x plus 4 times, and this is where we plug in all of this, negative 6x plus 27 equals negative 8. Sorry, my steps are a little bit off. Okay, so I rewrote this second equation, except for instead of y, I replaced that. I plugged in negative 6x plus 27. Okay, now we're going to go ahead and solve that down. I got to start with distributive property. 4 times negative 6x is negative 24x. 4 times 27, holy cow, I don't know. 4 times 27, 4 times 27, 108 plus 108 equals negative 8. So we did some distributive property. Now we're going to solve for x, right? So I'm going to combine like terms over here. Negative 5x minus 24x is negative 29x. drop down the other stuff. Okay. All my variables are to the left. That means I want to move that 108 to the right. Since it's positive, I subtract 108. Negative 29x, oops, sorry, that's 29. 29x equals negative 116. Okay, I've got some big numbers here. Make sure you use a calculator. I got to divide both sides by negative 29. So we have negative 116 divided by negative 29. I know it's positive, and guess what? It's positive before. Okay. Okay, so we got our x. We got half of the final answer. And if you want, you can kind of start filling in your final answer here. Solution. We know it's 4, comma, something. Okay. Step 3, substitute your answer. So substitute the answer you got for x right there into the equation from step 1. So we're going to go back to the first equation. Okay, and that's where I'm going to plug in this 4 for x. So I take this. You do not have to do the arrows. For some reason, it just helps me plug in. I don't know. So I'm going to take this top equation, and instead of x, I'm going to plug in 4 for x. So it's 6 times 4 plus y equals 27. Okay. I'm solving for y now. So 6 times 4 is 24. Got to get y by itself, so I subtract this 24 away. I get y equals 3. Okay, y is equal to 3. Last thing I do, I guess I could have had a step 4, but last thing you do is put your answer as an ordered pair. So your final answer here is 4, comma 3. Alrighty, isolate a variable, plug it in, solve for a variable, plug that in, solve for the other variable. That is substitution. Yes, it takes a long time. That's why we're not going to do a whole bunch of examples, but enough for you to get the hang of it. Okay, so here is we're calling this number 1, even though you just did an example. Number 1, 3x equals negative 2y plus 4. Second equation, 4x equals 4y minus 28. Okay. Okay, step 1 is to isolate one of your variables in either equation. So this is where we got to think, what's the easiest one going to be to isolate? We'll see how these x's are almost by themselves. All we would have to do in this first equation is divide everything by 3. But one thing I notice is if I divide everything by 3, negative 2 divided by 3, not a whole number. I'm going to be dealing with fractions. 4 divided by 3, not a whole number. I would be dealing with fractions. If you're okay with that, then whatever. Okay, but I'm going to hope that this one's nicer to us. To get this x by itself, I would divide every single term by 4. 4 divided by 4, 1. 28 divided by 4, 7. That's a whole heck of a lot better than fractions, to me at least, okay? So for step 1, I would suggest that we would isolate this one, okay? So 4x equals 4y minus 28. I'm going to divide every single term by 4 so that x is isolated. 4 divided by 4 is 1, and 1y is just y. Negative 28 divided by 4 gives us negative 7. So that's step 1. We isolated one of the variables. Cool. Now, this is the expression that I'm going to substitute in for x, since x is equal to it. This is the expression I'm going to substitute in for x into the other equation. So now I'm going to rewrite this equation, but wherever I see an x, I'm going to plug in y minus 7. So instead of 3x, it's 3 times y minus 7 equals negative 2y plus 4. Okay. We do some distributive property. We get 3y minus 21 equals negative 2y plus 4. Your variables are on opposite sides. You want to get them to the same side. So I am going to add 2y to both sides. Move over your y's. We get 5y minus 21 equals 4. Next, move that 21 over. Add 21 to both sides. Get 5y equals 25. To get y by itself, I just divide by whatever's attached to it. 25 divided by 5 is 5. Okay. So right here, for my solution, I know that 5 is my y value. I just need to figure out what x is. So to find x, I take this answer that we just found, and I'm going to plug in 5 for y, and we're going to go back to the other equation. Honestly, you can plug it into either equation, just being honest. But I'm going to go ahead and follow the steps that we did. So we have 4x equals 4 times my y value minus 28. Hopefully you can see that okay. Okay, 4 times 5 is 20. Need to solve that down still. 20 minus 28, negative 8. So 4x equals negative 8. Divide both sides by 4. I get x equals negative 2. So final answer here is negative 2, 5. All right, I'm going to do 2 more. Here's number 2. First equation, x plus 5y equals 4. X plus 5y equals 4. Second equation, 3x plus 15y equals negative 1. That's the 15, by the way. Okay. Alrighty. So first thing, we see which variable would be easiest to get by itself. Notice how this y has a coefficient, this y has a coefficient, this x has a coefficient. This x doesn't though. That's going to be the best, easiest one for us to isolate. You can do the others. We're still going to get the same answer. It's just going to be harder math for you. Okay. So I would recommend getting this x by itself. And how we do that is we move that 5y to the other side. Some of you just know in your gut that if you move a term to the opposite side, you just need to simply change its sign. So if we move this 5y to the right, it would change to a negative 5y over there. And if you know that, I'm fine with you just doing it. Some of you need to see it. You need to see why it becomes negative, and it's because we're subtracting 5y. So we get x equals negative 5y plus 4. Okay, so we have one of our variables isolated. Cool. We're going to take this expression and we're going to plug it in somewhere. Where do we plug it in? Well, this was the equation we isolated. So we're going to actually plug it into that bottom equation, the other one. And we're going to be replacing x with negative 5y plus 4. So we have 3 times negative 5y plus 4 plus 15y equals negative 1. Whew, okay. So distributive property comes first, always. 3 times negative 5y is negative 15y. 3 times 4, 12. Drop down my other stuff. Okay. I need to combine like terms on the left. So I can put my y's together and then look what happens. Negative 15y plus 15y. That's 0y. It cancels. I'm not even going to write 0y because 0 times y is just 0. So what's the point? So I show that they cancel out and I'm left with 12 equals negative 1. So my variable terms canceled and I'm left with a false statement. You remember what happens here? No solution. This is an example of a system that has no solution, okay? One of the things that we talked about when we did graphing, graphing to find the solution, what happens if you have two lines that are parallel? So maybe they're like that and not like that. If you have parallel lines, they never intersect, which means there's no solution. This would be an example of lines that have the same slope. Since they have the same slope, they don't intersect. There's no solution. Okay? Okay. Last one, and this is the one that you're going to be doing as your practice question. I'm going to help you a little bit, help you get started, and then you got to finish it up with me. Here you go. X minus 2y equals 8. Second equation, 3x plus 5y equals 13. Okay, we got to choose which variable would be easiest to isolate. I hope you see it. X doesn't have a coefficient, which means it's going to be easiest. Okay, so to get that x isolated, I would need to move over the 2y. We just talked about how if you move a term over to the opposite side of the equal sign, it changes sign, right? So since this is a negative 2y on the left, if we suddenly move it to the right, it becomes, oops, I didn't mean to do that. It becomes positive. X equals 2y plus 8. My bad, okay? If you want to show that you add 2y, do it, that's fine. Some of you I know are just like, we get it, Miss Meineke, move on. Okay, so this is the expression that you are going to plug in to the other equation. So your other equation, 3 times, and instead of x, we plug in 2y plus 8 plus 5y equals 13. Okay, so I'm going to let you do the rest. You're going to distribute, you're going to solve for y. Whatever you get for y, you're going to plug in for y in either equation and get x by itself. Okay, I promise we'll do more examples in class in case this is still weird to you. I get it, it's a weird thing. Okay, good luck, have fun. See you later. Bye, guys.